So 2022 ADMA paper 2 question 11. The diagram below shows a cuboid with a base of sides 2x centimeters and x centimeters. Given that the total surface area is 432 square centimeters, show that the height h of the cuboid is given by this. So we know that the total surface area of this, in additional math we normally use an A, is given by, you get a 2 and find the area of each face. Remember, we have 2 of these faces, we have 2 of these faces, and we have 2 of these faces. So you can just get a 2 and find the product of each of the faces. So you can say LB for this and this, the floor, and then the floor and the roof, if I may call them that, and then plus for this face you can say B times H, and then for this face you can say L times H, like this. So just make sure that nothing is appearing twice in here. And then our A is 432, so you don't need to write A there. So 432 is equal to 2. Then our LB, 2x times that. So you can say 2x times x, this will be 2x squared, plus our BH. Our BH will be this times this, so that will be XH, and then plus our LH, this times this. Remember, if this is H, then this is also H. So 2x times H will be 2XH. Then these two are like terms, so we can add them. This plus this will be 3XH. So now at this point, you can either divide both sides by 2 to get rid of this and reduce your numbers, or you can just leave it like this. So I'm going to expand to minimize confusions. You can try to divide both sides and you realize that the answer will still be the same. So this times this will be 4x squared, this times this will be 6xh, and I think since we have a 6x here, I think we may not need to do that, but even if you do it, you will just be required to multiply everything by 2. Okay, so our job is to make h the subject of the formula. So I can just take this guy this side, and then we have 6xh. And then to make h the subject of the formula, I'll divide both sides by 6h. And my h will be equal to, let me write the h this side, 432 minus 4x squared over 6x. Let's compare and see if we are required to make any divisions or multiplications or modifications of any kind. So we have 432 minus 4x squared over 6x as required. So we are done. And then on part B, we have find the value of x for which the volume of the cuboid is stationary. So in this case, we have this. We don't have the volume formula. So you don't have to find dh dx here, because we've been told that we are dealing with the volume here. So the volume of a cuboid is given by base area times height. So you can say base area times height. You can treat this as your base and then multiply it by the height, and it really doesn't matter since these are all rectangles. You can treat any of the sides as the base. So I'll treat the actual base as the base. So our base will be this. So you can say 2x times this, 2x times x, and then times height, which is h. So our v will be this times this is 2x squared, and then h. So now we know what the h is. The h is this. So we can simply say v is equal to 2x squared And then our h is 432 minus 4x squared, everything over 6x. So I can reduce my numbers. A 2 can go there 3 times, and then a 3 can go into x squared, x times. So we have x multiplied by that over 3. So now let's just expand. So x times this will be 432x, then x times that will be 4x cubed. Everything over 3. Remember the x is gone. So now we can separate these to make it easy for us to differentiate. So this one will be, can 3 go into that? 6, yes, 3 can go into 432. So 3 into 4 is 1, remainder 1. 3 into 13 is 4. And then 3 into 14 is 3. That's a 4. So we have 144x, and then this one will simply be 4 over 3 x cubed. So how did I know that 3 can go into this? So for 3, only for 3, you can just add all the numbers and check if the sum is a multiple of 3. So if I add this to this, I have the 7. I add this to that, I have a 9. And then 3 can go into 9. That means this number can also be divided by 3. So the question is saying find the value of x for which the volume of the cuboid is stationary. So you can just differentiate this and bear in mind that at stationary points, dy dx is equal to 0. In this case, we have dv dx. So let's differentiate this. dv dx is equal to, when you differentiate this, you have 144. You differentiate this, this will simply be 4. Okay, let me just show everything. So we have a 3 this side, and then this and this will cancel out, so that dv dx is equal to 144 minus 4x squared. So now to solve this, remember that at the stationary point, dv dx is equal to 0. So we can say this thing here is equal to 0. So I've just substituted 0 on dv dx. Then we have 4x squared. You can take this one to the other side. Then you have 4x squared is equal to 144. And then I can divide both sides by 4. And then introduce the square root on both sides. Let me just do it from here. Can 4 go into this? Yes. 4 into 14 is 3. Remember, 4 into 24, that's a 6. So you can now introduce the square root. So why am I not putting plus or minus here? These are dimensions. X and h are just dimensions. These are not like any other numbers. We're dealing with dimensions of a cuboid. I don't think we have any negative lengths. So x is 6. Of course, these are centimeters. And then, are we looking for x? Find the value of x for which the value of the volume of the cuboid is stationary. Yes, we are looking for x. So x is equal to 6. And then finally, we have this last part. Hence, determine the nature of the stationary point. So to find the nature of the stationary point, we use d2y dx2. And then if this is greater than 0, then we have the minimum. And then if d2y dx2 is less than 0, then we have the maximum. It's quite the opposite. I know you expect greater than to be max and less than to be minimum, but it's quite the opposite. So our dv dx, remember we're not dealing with dy dx, our dv dx is equal to 144 minus 4x squared. So I can simply differentiate this thing again. d2v dx2, this will give us negative 8x. And then since x is equal to 6, we can say d2v dx2 when x is equal to 6 will be negative 8 multiplied by 6, and then this times this will give us negative 48. And as you can see, negative 48 is less than 0. So if negative 48, if dv dx, if d2v dx2 is less than x, then we can apply this thing here and conclude that we have a maximum volume, hence determine the nature of the stationary point. So that means we have the maximum here, and we are done.